So the triangular numbers, we need to prove this sequence. So the theorem, the closed form expression for the nth triangle number is the triangular number is the summation of I is equal to I is equal to 1 to n, which is I is equal to n multiplied by n plus 1 all over 2. Prove this by induction. So the basis for the induction, when n is equal to y, we have the summation of I is equal to 1, the summation from I is equal to 1 to n, which is I is equal to 1. It also the n multiplied by n plus 1 all over 2 is equal to 1. So let us now substitute. So 1 multiplied by 1 plus 1 all over 2 is equal to 1 multiplied by 2 is equal to I divided by 2 is equal to 1. So this is our base case, and the induction hypothesis is the summation of from I is equal to 1 to k, which is I is equal to k multiplied by k plus 1 all over 2. So this is our induction hypothesis. It is to be demonstrated that the summation of from I is equal to 1 to n plus 1, which I is equal to k plus 1 multiplied by k plus 2 all over 2. So in the induction step, this is our induction step. First, consider the n is equal to k plus 1 by the properties of summation. So the summation from I is equal to 1 to k plus 1, which I is equal to summation of from I is equal to 1 to k, I plus k plus 1. So using the induction hypothesis, this can be simplified to k multiplied by k plus 1 all over 2 plus k plus 1 is equal to k multiplied by k plus 1 plus 2k plus 2 all over 2. And it is equal to k squared plus 3k plus 2 all over 2 is equal to k plus 1 multiplied by k plus 2 all over 2. So we need to factor out the k squared plus 3k plus 2. So is equal to k plus 1 multiplied by k plus 1 all over 2 is equal to k multiplied by k plus 1 all over 2. And now we have moved on the sum of the triangular number sequence. So proof by induction, one of the proof of some triangular numbers is by induction. So the triangular number, or the Tn, is equal to n multiplied by n plus 1 multiplied by n plus 2 is all over 6. So we can prove this in an inductive way. So this is a base case. If n is equal to 1, then the T1 is equal to 1 plus 1 multiplied by 1 plus 1 multiplied by 1 plus 2 all over 6 is equal to 1 multiplied by 3 multiplied by 3 1 multiplied by 2 multiplied by 3 all over 6 or divided by 6 is equal to 1. So let n is equal to k. We have the t n plus 1 is equal to tn plus tn plus 1. So therefore the the sum of triangular number is equal to tk plus the tk plus 1. So let us now substitute the tk. So this k multiplied by k plus 1 multiplied by k plus 2 all over 6 is this. So we need to substitute the n into k. So plus k plus 1 multiplied by k plus 2 divided by 2. So this is the triangular number. So evaluate this. So we have k multiplied by k plus 1 multiplied by k plus 2 plus 3 multiplied by k plus 1 multiplied by k plus 2 all over 6 is equal to k multiplied by k plus 1 multiply by k plus 2, multiply by k plus 3, all over 6. Since the key triangular number is tk is equal to k plus 1, k multiplied by k plus 1 divided by 2. So our sum is the summation of from I is equal to 1 to n, and the k multiplied by k plus 1 divided by 2 is equal to 1/2 summation of from k is equal to 1 to n. So k squared plus summation of k is equal to 1 from 2 and k. So the second summation is the Tn, and the first summation is 1/3 n multiplied by n plus 1/2 multiplied by n plus 1. So these are the TR. So substitute the n to r. So this is the binomial equation. So r plus 1 choose 2 is equal to r multiplied by r plus 1 divided by 2. So our Tn is equal to summation from I is equal to 1 to n, the TR. So is equal to summation of from I is equal to 1 to n. So let us now substitute the TR from the r plus 1 choose 2 is equal to the n plus 2 choose 3. So is equal to n multiplied by n plus 1 multiplied by n plus 2 is equal to 6. So we can get the pattern by subtracting the triangles, which are 12 minus 3 is equal to 9, 28 minus 12 is equal to 16, 53 minus 28 is 25, and 89 minus 53 is 36. So since di pa sila nagkaroon ng same value, we need to subtract this again. So 16 minus 9 is 7, 25 minus 16 is 9, 36 minus 25 is 11. So we need to subtract it again. So 9 minus 7 is 2, and 11 minus 9 is 2. So the pattern needed to be subtracted thrice to equalize. So it means the pattern had the degree of 3. So using the equation for unknown, we know that the A is equal to 1/3, B is equal to 3 halves, and C is equal to 13 over 6, and D is equal to -1. So therefore the equation is 1/3 n cubed plus 3 halves n squared plus 13 6 n minus 1. So step 4, look back. We learned that if there exists a pattern, difference will be equal if you subtract consecutive numbers enough times. So it is important to draw first the given problem in order to count the triangles. We have come up with a general formula 1/3 n cubed plus 3 halves n squared plus 13 6 n minus 1 to find out how many triangles were formed if the given points were more. So again, this is Jason Balatbat, and thank you for listening.